Yeah, then hello. My name is Tim. I'm the CEO of ekkodale, a software company in Wiesbaden. And why I'm here, though, yeah, maybe this sentence is not so spectacular for the audience here, but for the rest of the software AECO ecosystem, it is something new. So that we focus on open software. We have roughly 30 years experience of software development. Started also from proprietary plugins for Revit, stuff like that, and switch now more and more and try to do our best to make things open. What we do, I try to explain a little bit. Yeah, we have maybe a lot of representations of what we built, so nothing new to you. But we have also on the other side a lot of non-modeled things in our building industry and in the projects. And yeah, that's what we try to bring together so that we not only focusing on 3D, 2D, BIM, whatever we call it, geometry, schematics. So I have a little bit background in MEP, so all these schematic drawings and so on with symbols and attributes in AutoCAD and all these fantastic things, decoupled silos. Yeah, what we try to achieve is that the data is available, but freely available. We have CDE platforms, a lot of them in the projects. I guess none of them is really open, so it's proprietary software, so you put in your data. And that's what we don't want to build a CDE, but we want to make it accessible. What we always try to remember, there are things out there we should use. So I guess you have heard yesterday's talk from Philip Domen about ontologies, turtle, RDF stuff, and so on. Schema.org was yesterday a big topic, and all these technologies out there are ready to use. And that's what we try to bring together now in our project. We build here on a lot of technologies, open source, that is, or semi-open source, if Neo4j. I don't know who's working with graph databases here. Someone experience? So Neo4j is a graph database. It's not like Postgre, where you have relational or document-based data. Keycloak for authorization, authentication. Someone using it or in the projects? So if you have to authorize in your application, don't write it by yourself. You can make all these problems and errors many people did before. So use something like that, integrate it. Or min.io, if you have to have a storage in your system and you need to persist files to in a cloud environment, you can do it by yourself. But I strongly advise don't do it. That's what we try to combine here. Kafka I will talk a little bit about later. On the other hand, we have open stuff like Speckle, Blender, IFC. Yes, we have an open standard, but the most implementations are proprietary. And then we have all our beloved BIM modeling software if we create geometry. But yeah, this is the modeling part, the project part where we create fancy buildings. The question is, what do we do with all these things that are not modeled or system structure? So not structure from the structural point of view, but connected things. So like IoT bus in the background. No one hopefully will draw cables and wires in the BIM model. So we have to deal with these things. Yeah, and that's, I want to shortly describe how we develop this platform as an infrastructure that takes care about connected information for the AECO industry, but theoretically it could be used for everything. And what we did. I try to keep it simple. If you have questions later on, we can dive into the details. The first thing is we use taxonomies. You have heard also about yesterday a little bit, so it's a language. We talk about classifications and parameters. So simple example, you have a door. In IFC, it's an IFC door, and it has a lot of properties collected in p-sets. So that's one taxonomy. An example is IFC is one of the languages we all can understand, but we have a lot of them around there. So Germany is quite good in creating standards, and every organization creates another standard, so a new language with their own scope in their own area. And Germany is not alone. So if we take a look worldwide, we have a lot of these languages. So under the hood, classification and properties. And for example, the length, how is it described? Do we have meter, millimeter? What are the units and stuff like that? So that's all taxonomy part. The other thing is we need to connect these things. That's also what Philip yesterday shortly described. So we talk about ontologies. We separate these things. I know if we are experts in ontologies, you can do everything in one technology. We try to separate it. One example that you get an idea of what we're talking about. It's a bot ontology. We connect spaces, sites, and so on. It's a little bit comparable to what IFC is doing. So we have these links between the types, the objects, and on the other hand, the language. And we, of course, no ontology is complete. So you will have the problem that you need to connect things around in specific areas and link them together. That's what we focus on. So we create a platform that takes care about language definitions, all these things, connections between the objects. And here we create a quite complex system based on a microservice architecture and so on, with authentication, everything. So you can control who has access to this parameter in the door for a specific use case and so on. So that's what the platform will do for you. On the other hand, we invested some time to make it modular because, for example, we get data from an IFC file or from IFC projects. Push it into the platform. If my language is IFC, then it's quite easy. So you have an IFC door, and we can push it into the system. Then we have, of course, systems like Speckle with all the connectors and all these things that are coming from Rhino, Revit, ETABS, whatever, in a structured way, and we push it into the platform. We don't care about geometry. So geometry is fine, but we care about connection of information. On the other hand, we have, of course, BIM tool number one, Excel, with semi-structured data. That's something you, of course, have to be able to integrate. So these are all modules you can create. And then the question is, how will these things communicate with each other? Traditionally, or today, also yesterday, I heard a lot about APIs. Everyone's creating an API. You all have to take care about the versions of the API and so on. And if the more things you connect, the more bottlenecks you probably will create. Because if you have a service behind a service behind a service, and they are all connected with APIs, and you get a call from outside, and it's going deep into the system and getting back, then you get timeouts. And then you have to think about different architectural patterns. And that's where our beloved Kafka comes in. We have as a foundation below our system. So someone using already event sourcing topics? No? Okay, so the difference is here, we have a message broker, it's Kafka, And it works like a radio station a little bit. So you have on the left side a producer. Then we have Kafka. You can run it as a cluster or keep it simple, just one instance. If you make it really rock solid and so on, then you have a Kafka cluster running. And there you create so-called topics. It's like a radio channel. So one is sending information on one side, and many can listen on the other side and get this notification. The nice thing is, it is also something like a persistent layer. So you send something, and Kafka keeps track of storing this information. So you get a change history above your, on top of your data for free. So you know exactly who changed what and when. Nice thing, and makes the system extremely scalable. What we, on top of that, integrated, the platform is in a modular concept. We implement this at the moment together. I don't know if he's here, Louis, or is sitting there. So Louis creates an LCA app connected to this platform. So because we don't know how LCA works, we can take care about the information we want to connect. That's our business. Louis exactly knows how to do this. And we created a modular concept. Someone maybe using already micro front-end technologies, something like that? No? Okay, so it's something like a plugin technology for web apps. So Louis can create in his domain everything he needs for the LCA stuff. It's combined in this domain. We don't care about 10 services behind one service, doesn't matter. And the platform and the LCA app in this case, communicating through these topics. Then you can, of course, create other apps like a cost app, also Louis doing. It could be your app as a module connected to the system. And another thing could be a dashboard. So in Power BI, whatever, web-based, whatever you want. Yeah? So we combine several concepts, make it as scalable as possible, make this language thing available so that everyone knows we have a door and it has a parameter length. So this, in domain-driven design, ubiquitous language. So we have a common language that everyone understands, and connected to the outside. So the main idea is to make this thing openly available so that we have information hub, and helps hopefully a lot of developers out there to do their business in their domain and not focusing on how to persist data in graphs or stuff like that. So that's what we want to do, to create a structured layer below that. Yeah, we are in Wiesbaden, small team focusing on that. So if you're in the center of Germany, you're totally welcome to have a coffee. And that's it, the idea, what we do.